All right, so we have got our special meeting. This is Thursday, May 16th again, 2 p.m. And this is a hybrid meeting. And basically, everybody who was here before is still here. So we will just go ahead and proceed right into our agenda. And our agenda does start with a call to order, which I've just called us to order. And they were on the discussion item, which is what we've all been waiting for. Yes, this is the presentation on the cost estimate benefit cost analysis. So please proceed.
Thank you, President Palmer. I think before we jump into it, Carrie, would you be okay introducing Dr. Dave Sunding before we get into it?
Sure. I would like to introduce Dr. Sunding to the board. David Sunding is an emeritus Thomas J. Graff professor at UC Berkeley. He is the founder of the Berkeley Water Center and a professor at Berkeley's College of Natural Resources and School of Law. He is also a consultant at the Berkeley Research Group, an economic consulting firm that has been under contract to DWR to complete the benefit cost analysis of the DCP. So we're so glad he could join us today.
Great. Thank you, Carrie. So I'm going to start out the presentation first with the cost estimate update, and then we're going to transition into Dr. Sunding's presentation on the benefit cost analysis. There is a lot of information included here. So I will just want to point out that we do have public reports that have been made available. They're posted on our website. When we get to the end of this presentation, there are links to I think the information that we are hosting on our website, which also has links to the benefit cost analysis, which is being hosted and shared with the public through DWR's website. So for any who might be thinking they need to rapidly take pictures or scribble, that all this information is available and is out there for anyone who wants to take a look. So with that, I'm going to try and proceed. First, I'll start with estimating scope and methodology. Then get right into the estimate update. It's in $2023, hence flagging it as 2023. We do have a secondary estimate that we're also looking at. This is incorporating some potential innovations just to provide some insight into how the project can evolve through value engineering. Then next steps and questions, and then immediately through that, we will roll into Dr. Sunding's presentation on the benefit cost analysis. So although it is kind of one item, this is the agenda for the first piece of it. So I'm going to start by asking myself a few questions, I guess, to get some information out that I think is important to set the context here. First, when was the last estimate? I think everyone knows in 2020, the DCA issued a cost assessment. That was for something that more closely resembled the central alignment. The cost of that project is $15.9 billion, estimated in 2020 dollars. Again, that's undiscounted, which is an economic term, meaning it does not account for the time value of money. So why are we issuing an estimate now? So first of all, we've been talking about this. The Department of Water Resources selected a preferred project for further study. That is the Bethany Reservoir alignment. It's the perfect opportunity now to update the cost using all the improved engineering information that we've developed, update those dollars to 2023 dollars. There has been quite a bit of inflation from 2020 to 2023. And that really helps to tee that information up as key input into the economic feasibility analyses that you're going to hear in the second half of the presentation. In terms of the DCA's work, it also helps us identify areas of potential cost management. These are areas where it's helpful for us to see where the majority of the costs lie, where we might really get the most bang for our buck in terms of value engineering in the future. The next question, will the estimate be updated again in the future? Absolutely. This is an estimate that's being prepared in 2023 real prices. Again, that's an economic term that Dr. Sunding can fully define, but the point is this is intended to support an apples to apples comparison in the benefit cost analysis. So it's helpful for us on the cost estimating side to prepare it in a consistent dollar basis. So we've prepared this estimate in 2023 and the benefit cost analysis really takes it from there. We will need to do future evaluations of project costs down the road. Ultimately, if the project does continue on, there would be a need to establish the budget for implementation. So this is by no means the last time we're going to be talking about costs on this program. We also have a lot of ideas and ways that we want to improve and manage the costs on this program. So this is something that's going to be a very intense focus for the next few years. So what did we estimate? Sorry. Trigger finger. Okay. What did we estimate? It's the Bethany Reservoir alignment, 6,000 cubic foot per second project. I would characterize it overall as a 10% approximate design level. Some aspects of the project are better defined than others, and that's largely based on the availability of subsurface information. If you actually at some point go to the cost estimating report, there's a checklist in there that goes through the design maturity. And that's a process of looking at all the aspects of the project and evaluating the level of maturity, which helps you sort of center on what you think the estimate class is. So this is all fully evaluated in detail and documented in the cost estimating report. But overall, it's a roughly 10% design. We've got the costs broken into two major areas. The construction costs are that column on the left. So that's all of the hard infrastructure aspects of the project. It does have its own contingency associated with construction costs. Then we've got the other major category that we call other program costs. And so that's for all the labor associated with design, management, oversight, also the land acquisition, mitigation projects that are identified in the EIR. Those are included in the cost estimate under the other program cost side. We've also got power, the settlement agreement project for Contra Costa Water District, the community benefits program, and then also its own version of contingency within other program costs. So in terms of our methodology, we did use what we often call a bottoms-up cost estimating approach. That's for the primary or really the main effort of the estimate was developed that way. In essence, what it means is we're taking into account consideration of the schedule, the equipment, the labor. So we're really building our way up to an estimate at this stage, what is approximately a 10% stage. That's not always the case. That wasn't the approach back in 2020. It wasn't that level of information was not available to provide that type of approach. But we have the information. We've been working on it and developed this estimate from the ground up. So that's really thinking through those individual aspects of performing the work. As I mentioned, it's 2023 real prices, undiscounted. The reconciliation process that I'll highlight for you was also performed not only on the construction costs, but as well as the other program labor costs. And then ultimately, we're able to reconcile this estimate with the old 2020 and see how it compares. We do have contingency and risk treatment costs included to account for uncertain items. And then just to clarify, we've assumed design bid build procurement at this point, just to keep the estimates conservative and recognize that is authority that we clearly have at this point in terms of contract delivery. So this is the schedule. We needed to develop and share a schedule with the economics team. This is the basis for the bottoms up estimating that I described. The main categories are listed on the left-hand side of the graph. We show those major permitting activities continuing through 2026. Procurement, just in terms of big picture procurement. The various design stages of the project are then grouped in green, followed by construction activities. The construction activities are key. Those really represent the start of significant investment and significant incurrence of cost. So those activities would start on preliminary or primarily on early works, making sure we've got the power in place, all the access roads, everything that's necessary to begin the major construction activities on the critical path features. The tunnels are on the critical path, so you see those are right behind, but actual tunnel excavation would not begin for a few years after the start of that bar. It takes some time to get the shaft built, the earthwork associated with building the pad, which requires ground improvement, the shaft itself, getting the TBMs on order to the site, assembled and ready for excavation. So in case you're wondering, tunnel excavation in this case really occurs in around 2034. So it's that period of time that's needed to ramp up and begin tunnel excavation. I'll say the peak expenditures on the project occur in the 2036, 2037 timeframe. At that point, there's 4 tunnel reaches running concurrently, as well as pumping plant intake, aqueducts, sort of many of the major elements of the project are all under construction concurrently at that point. Then it winds down, majority of major construction activities done in 2042. System startup commissioning completed by end of 44 with the system ready for operation in 45. So in terms of an estimate classification, we would classify this as a 4, according to the Association for Advancement of Cost Engineering. The Class 4 estimate still contains some Class 5 aspects. As I mentioned, mainly the tunnel alignment is probably the area with the most limited information and therefore doesn't approach the Class 4 designation. So the graphic on the left kind of helps to depict that. You can see that there, in reality, these classes tend to overlap conceptually. It is completely acceptable and entirely normal to have various components of the project at different stages based on what you're able to know and understand and clarify through project definition. What we show on the left-hand side is what's often called the limits of accuracy associated with an estimate. And again, this is AACE guidance. When you talk about cost estimates, it's really thinking about it almost like a bell curve. And those two lines, the blue line on the top, the yellow line on the bottom, those would represent pretty close to the tails of that bell curve. And then the opinion of the most probable cost would be the peak of the curve. And so what you can see here is that the opinion of most probable cost is what would align with the estimate that we're providing. A lot of the work that we do and the work that we've been describing is what builds up to that position and allows us to feel confident about the opinion of most probable cost that we're identifying. According to AECE guidelines, there still is a range of accuracy associated with that, and it should be embraced and understood what it means, and then but acknowledging that we have a lot of opportunity to manage that and work our way through it. We feel good about the opinion of most probable cost. We have a tremendous amount of engineering and documentation around the project, even at this early stage. We've prepared several hundred design sheets for the various projects and even the preferred project. We've got a number of technical memoranda. We've done a lot of engineering analysis, but still probably the most limiting factor would be uncertainty around ground conditions. For the estimate, we've used deterministic approaches. So that's building up from bottoms up instead of using stochastic or statistical relationships, which is often done. We've replaced most of the cost allowances with actual material price quotes that we've obtained from different material providers for some of the really expensive elements, especially the pumps. So those have, that type of information is fed into the estimate. We do have a better understanding of ground conditions at the intakes and the pumping plant, which allows us to kind of dial in our thinking more so on those elements of the project. And then with the work we've been doing on schedule and risk management, we're able to much more comprehensively consider where those risks lie and where the opportunities are within the project and fully vet those through the engineering work that we're doing. So transitioning now into the updated cost estimate, I'll start with the number and then pull backwards into the details. So the total estimate is at the bottom of the sheet. The update is $20.12 billion in 2023 dollars. Looking at the left-hand side, you can see how this all sort of breaks out into the various major components of the estimate. About 3/4 of it is associated with the direct construction costs. That includes a 30% contingency associated with those elements of the project. Then we've got the other program costs, which include the labor aspects, land acquisition, mitigation, power, settlement agreements, and community benefits that consume the other 25% of the total estimate. We also looked at the percent of construction costs related to those labor and soft cost aspects of the estimate. The board will recall back in 2020, we sort of worked the other way. We used benchmarking with large scale projects to develop high level percents for these labor costs, and then worked our way into the labor costs in that direction. For this estimate, we've worked our way bottoms up for those soft costs, and then we're calculating the percent to provide context on that so that we can compare it with the old estimate. But we did it in the reverse direction. I hope that translates here. I think a couple other items to point out while I have the slide up. We do have the community benefits program identified, which is allocated, has a funding allocation of $200 million included in the project budget. Also included is the mitigation identified in the environmental impact report totaling $960 million. So all of that is included in the other program cost component of the estimate. So now we'll pull back and look at first the construction costs. So we're looking at that 2/3 of the pie chart, the $15 billion, looking now at the aspects of project construction. First, the methodology. We used heavy bid software. That's very common in the construction industry. That allows us to build up to these estimates based on the construction method and schedule of activities. We've developed a work breakdown structure for all of this so that the estimate aligns with our master program schedule. We've included prevailing wage, labor rates, equipment, material quotes, sales tax, markup, profit, insurance. Point being, this is a very complete and comprehensive estimate of all the construction costs associated with the project. In terms of our risk evaluations, we've also identified risk treatment costs. So where we can clearly identify potential risks within the program and feel like we have the ability to reduce that risk through direct implementation, we've developed the cost estimates around that and included those as risk treatment. Then we have construction contingency for the remaining risk associated with the project. So risk uncertainty is dealt with in two ways. One, in risk treatment, which is included directly, and then contingency, which is applied as a 30% multiplier before we get to that 15 billion. We did do, as I mentioned, a reconciliation process. So this is internal, starting with the DCA design team doing a lot of the bottoms up work, and then the program management team really taking more of a top-down approach to the estimate. What you see on the right-hand side here is a comparison table with the design team's numbers in black for each feature, the program management team numbers in red, and then the difference between the estimates in sort of the orange color. Initially, we had a cost differential of about 13% through those two different approaches, and then went through a reconciliation process. Mainly, it boiled down to different approaches and having more accurate estimates for material equipment, quotes from manufacturers. Some of those aspects are very expensive, as I mentioned, especially the pumps, for instance, down at the pumping plant. Looking at different intake structures, T-screens versus vertical flat panel screens. And then pumping plant itself, getting a lot of updated equipment from manufacturers and better understanding of ground conditions, construction sequence. A lot of that is information that the design team has the benefit of, and the management team's independent estimate really kind of works down more statistically, kind of, I'd say maybe a little bit more traditional at this early stage. So those two different approaches landed initially with a difference of 13%, but once we went through and worked all the differences out, came to agreement, came to consensus, we end up with a final reconciled cost difference of 2%. So actually less than 2%. So to me, that adds a lot of confidence to the estimate in terms of how we develop the construction cost using different approaches and then using this type of reconciliation process. Regarding construction contingency, as I described, we have settled on a 30% construction contingency. This was established based on a partnership between our estimating teams and the engineering teams. First, the biggest consideration is the overall design development maturity, which we would assign at roughly a 10% level of design. We did perform a semi-quantitative risk analysis to develop the amount of the dollar value of risk remaining within the project, and use that to also help back into an appropriate level of contingency. But then we certainly leave a lot of room for professional judgment at this point. That's a key part at these early stages. And so it was really kind of a three-step process, as you see those bullets listed, starting first with the maturity of the project, the semi-quantitative analysis, and then overlay of professional judgment and experience. The reality of contingency is that it will decrease as the engineering work advances. Those costs don't disappear, they just transfer from the contingency bucket over to the directly estimated aspects of the project. On the right-hand side, I just showed by comparison the contingency included in the 2020 estimate, which was 38%. That was really more of a judgment exercise back in 2020. We went feature by feature, looking at the conditions that we understood at the time, using experience and judgment to apply a contingency by feature, and then essentially aggregating that into an overall program contingency. I described, as you can see on the table, that approach is not even applicable at this point because we've done a much more rigorous, really bottoms-up analysis of the risk and contingency. And at this point, it isn't even entirely appropriate to look at it feature by feature. It's really something that we look at more comprehensively across the program. So in terms of our other program costs, there's a lot here. I'm not going to read all these words or numbers, but I think it's worth highlighting. So this is the other 1/4 portion of the pie slice that we saw at the beginning. Again, this is all bottoms up work to get to these numbers. I think really the key takeaway within the table, you can see those aspects or elements of the other program costs and the applied contingency. We used 30% contingency anywhere that had construction-related aspects of the project, even though we're in the other program costs, in terms of our cost estimate, there are portions of it that contain some amount of construction. And so that would include the power construction, that would include habitat restoration projects. We also wanted to be conservative and include a 30% contingency on land acquisition costs. When it comes down to labor costs, we use 15%. And in a couple of spots, we assign 0% contingency at this point because we consider those numbers to be hard numbers within the estimate. Sorry, I keep clicking, but it's not moving. Okay. So I have a comparison now to the 2020 cost assessment. So there's a couple of ways to think about this. What I've shown in gold is the updated 2023 estimate with 20.12 billion as the total number at the bottom. You'll recall that the 2020 cost assessment had a total cost of 15.9 billion shown at the total bottom. This is not an entirely apples to apples estimate, but we've done our best to allocate things properly and provide for a reasonable comparison. The real consideration here is that according to the U.S. Bureau of Reclamation's construction cost indices, there's been 26.8% escalation, inflation from 2020 through the third quarter of 2023. So that 26.8% is quite an increase. And when you take that 26.8% and apply it to the 15.9 billion, that's where you arrive at an escalated number. But I want to just pause for a minute though and look more specifically at what we've done here. So we took the construction costs at the top, which back in 2020 totaled 12.1, and you can see that number at the very top of the column there. So all of those construction costs were escalated using the 26.8%. Then drop down next into the other program cost. We took all the labor costs, which you can see there just for reference, were based on a 25.5% of construction cost estimate. And I'll just say as an aside, that compares to our updated 22.2%. So we've got a much more refined estimate of soft costs. But we took that amount, all that labor, escalated it to the right using that 26.8%. Then as we move down into other costs, we escalated land, escalated mitigation. Power was actually included in construction back in 2020. And then we did not escalate any of the items down below because they didn't exist back in 15.9 or back in 2020. But when you do this escalation process, you arrive at 20.17, which is very close, very similar to where we are with 20.12. So again, this adds confidence. Two estimates approached very differently. The updated estimate, we've got a tremendous amount of work building up to it. But just using this as a benchmark to say, what did we do in 2020? We did good work in 2020. We included appropriate contingency and placeholders and allowances, and escalating that number really does get us to a very similar place in terms of total program costs. So now I'm going to shift gears into what we're calling the secondary estimate. These are a variety of cost reducing innovations that we're starting to consider. There are some important points here, I think, when broaching the topic of innovations. First of all, from an engineering perspective, the work that was provided to DWR for their impact analyses and the work that's documented in our engineering project report represents a relatively conservative configuration. And that's because there's a lot of information we don't have yet. There's a lot we don't know, and where we needed to make assumptions, we have to make appropriately conservative assumptions. But at the same time, we understand that there are a number of innovations that represent opportunities to reduce impacts, reduce costs, schedule, or risk. We wanted to shed some light on those now. They're very informative to help communicate where we think the project could go through continued value engineering and continued data collection and understanding those conditions to just further understand and refine the configuration of the project. So we developed 19 innovations for inclusion in the secondary cost estimate. I want to be clear that these do not currently represent changes to the project description and will need to be fully analyzed by DWR with respect to any permit and especially CEQA applications that would be relevant. So here's an example of an innovation. This is the Bethany Reservoir Pumping Plant. On the left-hand side is a depiction of the current EPR design. So those are, that's entirely a below-ground structure with the exception of the ground surface that you see with the shade structure and the cranes at the surface. The rest of that is all below ground. There's a rectangular concrete wet well. That's the inlet from the vertical tunnel shaft at the surge basin that would be used to convey water into the wet well of the pumping plant. So it's a vertical box structure. And then the pump bays are constructed adjacent to that also as rectangular concrete structures. Those rectangular concrete structures are constructed using diaphragm walls, reinforced diaphragm walls, which require a lot of cross bracing. And then would be constructed using top-down methodology, meaning you start the excavation from the surface. After you've built all the walls in place, you start excavating inside the walls, construct the floors, construct the braces, and then start working underneath those floors, working your way down to the bottom of the excavation. So alternative, we looked as an innovation design using a tunnel drive, a very short tunnel drive launched from the reception shaft to actually excavate and replace the wet well. So we could have essentially a header that would excavate into the center of the pumping plant and then connect up to the pump bays that would be constructed using interlocking shafts, also diaphragm walls, but not requiring the same amount of cross bracing and support because of their inherent strength as interlocking shaft structures. In doing this, we're able to substantially reduce construction quantities. I mean, just to provide reference, it's 274,000 cubic yards of reduced soil excavation associated with this configuration, 84,000 cubic yards of concrete saved associated with this, 10,400 tons of rebar reduced associated with this. So major changes, major reductions potentially in construction quantities. But I'll point out that the above ground configuration really doesn't change, and all of this would occur within the site configuration that's currently identified. So it's sort of working more efficiently and smarter within the identified footprint. This reduces the construction schedule by 981 days and reduces direct construction costs by almost $140 million. And that's just direct construction before we apply soft costs and all the other risk treatment costs and other aspects of the project. So rolling those up by feature, we have various categories, intakes, tunnels and shafts, pumping plant, surge basin, aqueducts, discharge structure, logistics. What you see in the first column of numbers are the direct reductions in construction costs, about 750 million. Then we apply a proportional amount of the risk treatment costs. So that totals 24 million of additional savings, totaling 773. Then we take that number and estimate the total project costs with innovations using that same 30% contingency, and then direct application of scaled other costs. So this, we scale the labor costs, but as you can sort of work your way down the numbers, at this point, at this very early stage, we have not adjusted the land acquisition, mitigation power, or any of the other elements of the cost. We've just focused on the direct construction cost, contingency, and labor cost associated with these innovations. In doing so, we're able to reduce the total project cost by 1.23 billion, or approximately 6% of the total cost. And I will acknowledge that this does not account for reevaluation of risks and potential contingency changes. So that's a lot of further work that could still yield additional benefits from a cost perspective. We've not evaluated the potential benefits of those schedule reductions and how they could translate to actually shortening the overall project schedule. That relates to the critical path and will take quite a bit of work to sort out. We've not acknowledged potential reductions in any land requirements, reductions in potential mitigations. All of that would have to be fully considered by DWR before any discussions around that would occur. And then lastly, as I mentioned at the beginning, this entire analysis assumes design, bid, build, procurement. So we're not even talking about potential benefits of collaborative delivery contracting approaches, which could further shorten the overall construction schedule. So next steps on costs: analyze the economic feasibility of the project through benefit cost analyses and then agency-specific local economic studies. You're going to hear about the benefit cost in just a second. Continue development of the design, construction, contracting innovations to improve or refine project definition and constructability, and then support DWR's evaluation, including CEQA, of select innovations for possible changes to the approved project. All of those spill off of one another and would be potential future activities. So with that, I am going to hand the control to Dr. Sunding. I think we'll just keep rolling, President Palmer, if that's.
So you don't want to take questions from the board?
I think we'd like to keep going unless I would say if there's any real issues around the understanding that would hinder sort of moving into the next phase. Otherwise,
Next phase.
great.
Okay.
I think we should. Thank you.
Thank you. The song?
Yeah.
Yeah, there we go. Nice to be with you today and happy to talk about the economic analysis of the DCP that we've just completed. I should say we've been at this, my co-author and I, we've been at this for about 18 months with our staff looking at different aspects of the project and what it might mean in terms of water management across California. And we've come to some conclusions that we can share with you today.
Go ahead and click for him.
So just really quickly, probably some background that you're all very familiar with. The area that's served by the State Water Project, if it were a country in its own right, it would be the 8th largest economy in the world, just behind the UK and France, but larger than Italy, Canada, and Brazil. So it's a very impressive economic area. Currently, the State Water Project delivers about 2.56 million acre feet per year. That's on average, of course, across all types of water years.
The total California economy is like over 3 trillion.
Okay. All right. So our economic report looked at two major categories of benefits. Other benefits as well, but we really focused on 2 categories of benefits. First is the ability of the DCP to mitigate, not entirely eliminate, but mitigate the expected effects of climate change. And second, we looked at the ability of the DCP to improve conditions following a large seismic event. So basically to mitigate the effects of a large earthquake on the system. We took as an input for our analysis the updated cost estimate that was produced by the DCA that Graham just described. And that's 20.1 billion in undiscounted 2023 dollars. I should note that, as Graham explained, while that cost estimate is around $4 billion higher than the 2020 estimate, our assessment is that largely that's due to inflation. Everything is more expensive in 2023 than it was in 2020. And it's also true that while the costs have gone up due to inflation, the benefits have gone up as well, right? Those have been inflated too. So the overall effect of inflation on the benefit cost assessment is kind of secondary. But we do account for increases in costs and benefits due to inflation. And we also, as a sensitivity analysis, look at what happens to the benefit cost comparison if the supplemental design innovations that Graham was talking about come to pass. So what a benefit cost analysis does is just like what it sounds like. It's an assessment of what does it cost to invest in an intervention like the DCP, and then what do you get for it? So in terms of what you get for it, as I mentioned a minute ago, we put a lot of attention into the ability of the DCP to mitigate climate effects, both changes in climate, precipitation, but then also sea level rise. And then we also look at the ability of the DCP to improve conditions after an earthquake and maintain State Water Project deliveries. On the cost side, our intent was to be as comprehensive as possible and account for both cash and non-cash outlays. With respect to cash outlays, we used, as I mentioned, the DCA cost estimate for construction costs. We added in O&M costs going off throughout the study period. We included costs for environmental mitigation of almost $1 billion. We included the community benefits program at around $200 million. But then we also included things that are not cash outlays of the DCP, but are still economic impacts. And these are things, mainly local impacts in the Delta during the construction period, increased traffic congestion, lowered air quality, noise impacts. These are economic costs that are not a cash outlay, but they're real impacts to certain people. Then over the longer time period, a cost that we took a look at was the changes in salinity in the Delta that might impact farmers as a result of DCP operation. So again, our intent was to be comprehensive. Putting this all together, the bottom line conclusion is that we think the project has a benefit cost ratio of around 2.2 to 1. And what that means is that for every dollar spent, there's about $2.20 in benefits that are ultimately enjoyed by the State Water Project customers, right? Businesses and farmers and residential customers throughout the State Water Project service area. So some assumptions that go into the analysis. Again, we're in our primary scenario in the economic study, we're looking at 2070 hydrology. So future climate conditions that are projected to exist once the project begins operating. So we're looking at around 403,000 acre feet that are protected as a result of the DCP being implemented. Again, we have 20.1 billion in cost and undiscounted 2023 dollars. This is a little bit wonky, but it's important. Our analysis uses a discount rate of between 2 and 1.4%. We use a discount rate, we have to, because if you think about the time pattern of benefits and costs, the costs are expended first largely, and then the benefits start accruing once the project begins operating. So there's a mismatch there, and that's true for almost any infrastructure project. So to compare costs and benefits then, can't do it on a year by year basis. We have to bring that whole stream or those two streams of costs and benefits back to present dollar terms. And we do that using a time value of money of between 2 and 1.4%. Now, what we're doing here is we're following recent federal guidance that was issued by the Office of Management and Budget that sets the ground rules for federal economic analysis of infrastructure projects. This is brand new guidance, but it's something that economists have been advocating for decades. I worked on this when I worked at the White House, and we recommended exactly these changes, and it's just taken a little while for the OMB to finally get around to this. But the important point is we're following the federal playbook for how to discount future benefits and costs. We're assuming a 15-year construction period, and then we're looking at benefits and costs over a 100-year operating life of the project. So with respect to benefits quickly, again, we're looking at different categories of benefits. First thing we look at is the climate mitigation benefits on the State Water Project. More State Water Project deliveries, and not more relative to the status quo, but more relative to what would happen without the project. That allows agencies to fill storage more frequently, so they enter droughts with more water in reserve. What that means is that there are fewer periods of mandatory rationing for urban agencies and less severe rationing whenever it occurs, and that has an economic value to residences and to businesses. In the agricultural sector, we're using a somewhat different approach. Agriculture is a business, and so we're measuring the change in profitability of agriculture with and without the DCP. We have two approaches that we use there. The first is using a very commonly employed economic planning model called SWAP, or the Statewide Agricultural Production Model. It's used for all kinds of things in California. But we also take a look at water market transaction data to get a sense of what are farmers actually willing to pay for extra water supplies in different kinds of hydrologic years. So this graphic is very important because it sort of summarizes neatly what we're assuming about the ability of the DCP to mitigate climate effects. And I'll walk you through this left to right. So left represents the status quo, the column on the far left. Under 2020 hydrology, which is roughly what we have today, with current infrastructure, the State Water Project delivers about 2.56 million acre feet on average. So then the middle column is showing by 2070, with the existing infrastructure, what's the impact of climate change and sea level rise on State Water Project deliveries? And the calcium modeling that we're using, developed by DWR, it's included in the environmental impact report. What that shows is by 2070, without the DCP, State Water Project deliveries would drop by about 570,000 acre feet, almost a quarter. And you all work in the water business, that is a big change. That's a lot of water to lose off the system. So then what we're focusing in on in the economic analysis is the difference between the rightmost columns. And what that's showing, the middle column is showing what happens in 2070 without the DCP. The far right column is what happens under those climate conditions with the DCP. And you can see the increase is about 403,000 acre feet. So we don't get all the way back to the current level of deliveries, but it goes a long way towards stabilizing water supplies in the face of climate change and sea level rise. And that provides the bulk of the benefits that we're measuring. The DCP also impacts water quality because it's diverting more frequently from, or diverting to some extent from the North Delta that has less salinity. We're looking at salinity impacts across both urban customers and agricultural customers. In the urban sector, as you know, less saline water reduces treatment costs, it improves taste, extends the useful life of household appliances, and results in reduced costs of water softening. In the agricultural sector, reduced salinity improves the efficiency of water use. It reduces the amount of water that has to be used to flush salt out of the root zone, the so-called leaching fraction. So turning now to seismic benefits, which is another major category of benefits that we analyzed as part of the DCP. What we're using here is the Delta Flood Emergency Management Plan, so-called Scenario 1 in that document, and that they identify as being their primary planning scenario. That envisions a 500-year earthquake event, so a 1 in 500-year event, that would result in 50 levee breaches and 20 islands flooded. So we look at the outage and the water quality impacts of that, and then put an economic value to it relative to what would happen post-earthquake if the DCP were operating. To put a little more detail behind that, it's worth considering what might happen following an earthquake of this magnitude. Without the project, what the Flood Emergency Management Plan envisions in this primary planning scenario is a delta export disruption averaging around 203 days. So 203 days of no water at all on the State Water Project, followed by a period of 340 days with reduced quality water, highly saline water. And that's as the salt gets flushed from the system following an earthquake. With the project, by contrast, we look at two different scenarios. One, if the DCP operates for the full duration, just business as usual. So it has an ability to completely eliminate the effects of an earthquake. But we also look at a scenario where the benefits are limited to deliveries at the minimum public health and safety guidelines. So with respect to alternative water supplies, a question that we sometimes get is, okay, well, you're telling me that there's a level of future demand and the DCP might reduce available supply, or the climate change might reduce available supply. So that creates a gap future gap between supply and demand that you're putting a value to. Well, couldn't we fill that gap with alternative water supplies instead of the DCP, right? It's a reasonable question to ask. And our conclusion is that even if that were technically possible, and there are questions about whether or not there is 570,000 acre feet of local alternatives available, they're quite a bit more expensive than the DCP. The levelized cost of the incremental supply, so this is the 400,000 acre feet that's provided by the DCP, is about $1,325 per acre foot, which is less than half the cost of desalination on average, half the cost of recycling on average. There's a range in costs for individual recycling projects or desal projects, significantly less than the cost of stormwater capture, in the range of costs of water conservation. And I should note that we're assuming quite a bit of water conservation in our demand projections that we're using to calculate economic benefits. So it's not exactly an either or. Our analysis assumes both of these things occurs. It's also fair to point out that a lot of the simplest water conservation measures have already been done, right? So some of the cheapest conservation alternatives are no longer available. They've already been adopted. So it's reasonable to expect the cost of water conservation to go up in the future. So again, bottom line here, comparing the monetary value of costs and benefits, our conclusion is that in our main scenario where we're looking at 2070 climate conditions with 1.8 feet of sea level rise, benefits outweigh costs by a ratio of about 2.2 to 1. But because there's uncertainty about exactly how the future climate is going to evolve, we look at, like one normally does, we look at a number of scenarios for how climate change might occur and what would be the impact on the economic analysis. So take, for example, scenario 2. Scenario 2 we're looking at the same year, 2070, which is within the operating life of the project, same climate assumptions, but we're assuming 3.5 acre feet of sea level or feet of sea level rise instead of 1.8. So more sea level rise means the without project deliveries are even lower. With project deliveries are about the same. So the benefit cost ratio is even higher in that case because there's more water preserved. Just kind of for the avoidance of doubt, we also evaluated the economics of the project under the hydrologic conditions and climate conditions that would attain when the project begins operating. So we didn't look at any further deterioration in climate beyond the day it starts operating. Even in those conditions, the project passes a benefit cost test. So under the 2040 hydrology, and that's the last two columns of this table. So this demonstrates a property that in policy analysis we call robustness. You get the same conclusion under a variety of different assumptions. So that should provide some confidence in our results. Some other important considerations, many of these are outside the scope of our formal economic analysis, but are still for decision makers worth keeping in mind. The current concept is that with the DCP, the PWAs can transfer excess supplies and also relieve themselves of associated costs. So there could be some reallocation of costs and benefits. That provides some flexibility to agencies down the road. I should also point out that I mentioned earlier that we took a look at what I called non-monetary costs. So impacts experienced in the Delta as a result of construction of the DCP. And what we did there was we looked at categories of impacts that were identified in the EIR, and we narrowed down from that the impacts that are not considered to be fully mitigated. So the ones that have some remaining unmitigated impacts. And that includes, again, things like local air quality, noise, traffic congestion. These are real. But then we put a monetary value to it using standard methods. For example, the Federal Department of Transportation has a standard method for valuing traffic congestion because they do highway projects all over the country. So the monetary value of those local nuisances is about $167 million. Definitely not zero, but small in relation to the overall costs, and especially small in relation to the statewide benefits of the project. And also I would point out 167 million is less than the size of the community benefit fund. And we're including the costs of the community benefit fund, but not any of the benefits that might result from it. So there are other things that are outside the cost benefit analysis scope, but are still valuable, I think, to keep in mind. Probably most important there is the operational flexibility that the DCP provides. Our analysis works on a monthly time step. It's a long-term planning level analysis that I think is valid, but we're not operating at a daily time step. We look at a monthly time step. Because we do that, there are certain instances like what you had this year where there might be a period of a few days or weeks where there's an opportunity to grab some additional water with the DCP in place. And this year, for example, I'm sure you've heard this number before. If we had had the DCP operating now, we could have added 909,000 acre feet to state water project deliveries, which is about equivalent to the water held in Folsom Lake. So these opportunities can be significant. Again, didn't include any of the benefits associated with the community benefits program. This doesn't belong in a benefit cost analysis, but it's still a legitimate thing to ask. What are the job creation benefits of a project like this? That also is analyzed in the EIR. And the conclusion there is there are about 5,000 high-paying jobs that are going to result from this large-scale construction project, many of which would be in the Delta. And then finally, I'd point out that as a policy matter, stabilizing surface supplies in the way that the DCP does is consistent with the state's long-term objective of stabilizing groundwater resources. Right? If we lose 570,000 acre feet on the state water project system, that's going to create an incentive for both agricultural and urban customers to rely more heavily on groundwater, and starts to defeat the purpose of SGMA and other policies that are aimed at stabilizing groundwater resources. So this is the last slide I have, and then be happy to take questions. Another way of thinking about the results of our economic analysis is what happens if we don't do the DCP? There's one thing I like to remind people is that, in my view, maintaining the status quo in the Delta is not possible. Climate change is happening, population growth is happening, earthquake risks are always in the background. So maintaining the status quo is not possible. We have to choose one way or another which way are things going to change. Investing in the DCP is one pathway to go down. But what would it look like if we did nothing, which is something the state could do? My view is that that would be even more expensive than investing in the DCP. So we can't avoid an expenditure here. Doing nothing in many ways would be more expensive than constructing and operating the DCP. So what would that look like? Again, we'd have something like almost by a quarter, state water project deliveries would go down by 570,000 acre feet per year. So without the DCP, you have reduced reliability and flexibility with respect to state water project operations. You have more frequent and more severe water shortages as climate change erodes water supply reliability. You have this ongoing background risk of a major seismic event that could take the system out for months or years. And then you also have, without the DCP, an increased need to invest in more expensive alternative water supplies, which ultimately is going to fall back on ratepayers. So some of the indirect impacts of not investing in the DCP are higher rates for local agencies, impacts on employment and economic activity, especially in agriculture where farmers will be forced to fallow more frequently. And that's got all kinds of local implications for farm jobs and other jobs in the rural economy. And again, this idea that stabilizing surface supplies, without that, it's even harder to get sustainability in groundwater resources. So you've got this compatibility in policies. So the conclusion that we've come to, that I've come to, is that the cost of inaction, cost of not doing the DCP, is significantly larger than the cost of investing in it. So just again, some economic perspectives on what this project is about.
Great. Thank you very much. Okay, now, board, do you have questions for either of these gentlemen? Yes, no? Go, Director Anapata.
Thank you, President Palmer. That was quite thorough and a lot of information to digest. Appreciate that. I'm going to walk through a few things and maybe I'll have some other things that come to mind. But anyway, I'll move through a few things. Graham, I want to start with you with the cost estimate. You admit there's a line item there on accessways, roadways improvements, things like that, that are to support the construction, but have value and can have value being left, as a sort of improvement that's left for the local communities and so on. I just wanted to see if you had a perspective on that or yeah.
You're right. There's a lot of those opportunities. I think we tend to refer to those as integrated benefits or leave behinds. There are a number of examples that we tend to think about, but I think to really flesh those out, it's going to take a lot of community input and participation. We do, just a couple of examples. For instance, we have park and rides that we plan to construct to limit the amount of construction traffic getting to some of the sites. Those we have within the environmental document assume that those are going to get torn out and that land restored and reclaimed in some other way. Alternatively, they could be left behind. That could be something that if the community wanted it, could be left behind as leave behind infrastructure. Another example is fiber optic high-speed internet connections. We're laying a lot of utilities and it's really very, very simple and very easy to add extra strands, extra aspects of extra pieces of that fiber optic installation to allow for future connections. There's a host of potential examples like that. So I guess in this context, Adnan, the cost of those items is likely to be, as you can tell, the cost would be something less to not tear out that piece of infrastructure as opposed to tear it out. And we are not accounting for the benefits of that aspect of the project. So this is one of those pieces that we'll have to do more work on with the community is, when we get to the point where we're really starting to think hard about design and standing up additional community groups to work through those ideas and have an opportunity to talk about ways that we could make relatively minor adjustments and do something in addition to the community benefits program.
One more question on the cost estimate is I know you mentioned that you looked at for the innovations, the direct cost savings related to those innovations. And you'd mentioned you have not evaluated things like schedule impact if that item is on the critical path and now we've shortened. But I mean, can you sort of riff off, your professional opinion in terms of magnitude of those can be significant. I would assume if they're a good schedule impact, that could be a significant cost savings. So I don't know if you wanted to dive in a little bit more there.
Well, I think the easiest point of reference is that if you take the 20.1 billion and assume 3% annual inflation, that translates to, I think it's about $630 million per year in inflationary impacts. So any ability to condense the schedule, get to construction sooner, work more efficiently and get the project built and into operation so that those benefits start accruing is a huge benefit.
And I'll do one more question.
Go ahead.
Okay. Dr. Sunding, on your presentation, you had a slide there on the alternative supplies. Can you maybe talk to the consideration for the opportunity for that supply to be developed in certain geographic regions or not. And one of the things I think about, I work at a Mojave Water Agency is of the high desert region, the San Bernardino. Things like desalination don't really make sense, unless we maybe investment in desalination and exchange. But we got to have a working state water project system with water in it, which this project supports. Things like water conservation, those in desert communities, those have been really pressed down, right? There hasn't been much opportunity to sort of breathe, be loose about it, I suppose. So in that regard, can you talk to opportunity to develop these in different parts of the region and how that plays into your thought process?
Sure, there we go. So you're right, there are technical limits and other political limits on development of alternatives at this scale. Remember, we're talking about replacing 570,000 acre feet of state water project deliveries. So that would be what, 11 or 12 Poseidon desal projects, which, I'm not a politician, but I think it's very unlikely something like that is going to occur. Same thing with recycled water projects. The average size of a recycled water project in the state of California right now is about 2,000 acre feet per year. So it would take a lot of those to make a dent in the 570,000 acre feet that's lost. Stormwater capture, interesting, definitely happening. More of it's going to happen in the future. That also doesn't have the ability to backfill for a loss of 570,000 acre feet. So you're right. The unit costs, it's one way to think about comparing these alternatives, but there are limits to all of these possibilities.
All right. Go right ahead.
Dr. Tundick, thank you for your presentation. Excellent, very encouraging, I think, for our project. Question about the numbers on the acre feet per year benefit. In your last slide where we do nothing, we're going to lose 570,000 acre feet per year. Earlier in the presentation, if we build the project, we will recover 403,000 acre feet per year. Okay, so we're not going to get the entire 570 back by building DCP, correct?
That's correct. That's what the calcium modeling suggests. So it is an important message, I think. This project is not about increasing water supplies beyond the status quo. It's about maintaining as much as possible of what we already have. And I think those are two very different things.
Losing 570,000 acre feet per year is just not, well, you say it's not possible to do nothing, or it's not advisable. Second question I have on the interruption due to the seismic event, 203 days of export disruption and 340 days of increased salinity. I wasn't sure where I followed if there was a dollar sign put to that.
Oh, there is. So that's incorporated in the benefit estimation. So we have $38 billion in benefits that we're measuring as a result of the DCP over that 100-year operating life. The seismic benefits are rolled into that. The climate mitigation benefits, and in the report, we have broken down by category what the benefits result from. The seismic benefits are the largest component of the benefits by a good measure. But it's important to note that even if the seismic benefits aren't as big on average, a scenario like that where you have a 200-day total outage, imagine if that happened in 1991 or in 2015 when reservoirs were already depleted. So the range of possible outcomes following an earthquake is quite large. And the average in some ways masks what is really important. Is again, if we had 200 days of no state water project deliveries at the end of a drought like 91, it's hard to even calculate what would have happened at that point, but it would have been something that we've never seen before. So we make this point in the report, but here I'm just focusing on kind of average outcomes.
So I just, the cost that's assigned to that is lost economic activity, or are we going out somewhere and trying to find the replacement water that At present doesn't exist anywhere.
Yeah, it's some of everything. It's lost economic activity to the extent that businesses experience shortage. But then for residences, it's lost economic value. It's water that they would like to purchase that they can't. So there's all kinds of inconvenience that results from that. And expense like landscaping, you let that go and no lawns and things like that. But there's a lot of water use inside the home that can occur. Yes. Yeah, thank you.
Good to know.
Hey, I have a question that, see if I can word it properly. It's more of a question of your interpretation of a situation we have in agriculture versus the urban sector. In agriculture, and I think most people understand that the public water agencies are expected to pay for this in total. And on the agricultural side, to me, it's really not the farmer that's the end user. The end user is the person that receives the agricultural product, which is spread across California and actually the whole nation. All these products go everywhere. And so it's hard for me to understand on the agricultural side, the farmers, there's so many less. It's not like a urban where there's millions. Maybe they pay a couple bucks more a month or something. A farmer, he can't recover that. He's dependent on the economy and what the products are worth. He can't say, well, I have to a little bit more because I have to pay for this project, And so I'm just searching for your interpretation of my dilemma that I'm having a hard time to reconcile myself with agriculture.
Sure. So the way we looked at impacts on agriculture of, having the project versus not having the project is what's the value of the incremental supplies that are going to farmers? And the way we measure that is to try to model out what would farmers be willing to pay to get those acre feet back. Now, you're right. There are big changes that are occurring in agriculture in the San Joaquin Valley as a result of things like Sigma and other reductions in surface deliveries. In fact, we did some research 2 or 3 years ago where we came out with a projection that something like 1 acre in 5, something around 1 million acres in the San Joaquin Valley could come out of production, not even incorporating this, just as a result of Sigma and reduced surface water deliveries. That's kind of an astounding statistic if you think about it. You look around the San Joaquin Valley, 1 acre out of 5 is gone. It's not in farming anymore. So those are massive changes. And then you put the climate effects on top of what's already in place right now. And, the impacts are quite serious. So I understand your basic point. And in some ways, I think we've approached this conservatively, but, the context you mentioned is very real.
Very much for your opinions.
Thank you, President Palmer, and really appreciate, the thoroughness of the discussion. Certainly a lot to digest, and I feel like I'm back in graduate school. So hopefully there's no test before we get class dismissal here, but I did have a comment and a few questions. So I represent the Coachella Valley, and certainly I think the farming interests, that Director Millibar, brought to bear, was kind of resonating in my mind as well. And we're caught sort of like in a vice, like our friends at Metropolitan are, because we're the only suppliers in California that actually have supplies to both Colorado River and the State Water Project. And as we know, both of them are like under intense pressures. And And we are going through a fallowing program right now too. So your comments about fallowing is exactly right. You know, these are very difficult discussions. So I guess maybe a question for Graham on the cost numbers. So, you know, when we were looking at the increases, I think you showed the reclamation model is about 26% increase. And so if you kind of escalate it, that's about 6% a year compounded between 20 to 23, let's say. And I think that seems reasonable. But you actually went through the additional step of actually breaking things down and went through a bottoms up approach. I just want to make sure that I got that correctly, because on, you know, sort of my back on the envelope before coming in here, I was kind of projecting, okay, with these different kind of interest rates, you know, what those numbers would look like. But you actually went through and did it methodically.
Correct. I mean, I'll just confirm what you're saying, what your interpretation is right. We took on the new estimate completely independent, and we really interrogated every piece of it, worked our way through it, made sure we had our best possible understanding of sequence, and worked our way up to that number. Having the 2020 estimate or the cost assessment available to then use as a check, it was really helpful. It really helps us sort of feel like what we've done is appropriate, and it certainly adds confidence from my perspective in how we've developed this. Another way to think about it is to take the 20.12 and de-escalate it back to 2020, and it would take you right back to basically the same number that we issued in 2020, right around 15.9 billion. So the effects of inflation, you know, they're real, but in terms of the level of additional detail, we've included a number of new elements in this project. We've got included the community benefits program, a number of other aspects of the project, much higher costs associated with mitigation. But we've been able to really sharpen our pencil on the labor costs that we anticipate. I mean, I think these are things that a lot of folks thought intuitively should occur, but without doing all of the work that we did, what can you go by? You know, you can't just start cutting things because you think they should be cut. So this allowed us to have a much more detailed estimate, and then we can look at it and compare it to the 2020 and feel pretty solid that, yeah, we've been able to manage our way through this process, and I fully expect that we'll continue to manage our way through.
Right. And I think you and Dr. Sunning both kind of mentioned, you know, the additions, you know, like you said. So, you know, there's like over $1 billion worth of new benefits or costs that we're assigning, you know, to the mitigation as well as the community benefits, which, you know, wasn't necessarily included in as explicit detail, you know, back in the 2020 estimate. So I think, you know, it's great that you're able to kind of contain the costs, you know, in this framework. So maybe a question for Dr. Sunny on you know, on the cost benefits. So obviously, you know, as we kind of talked about, water is just going to get more valuable in the future. And, you know, I really appreciate this look at alternatives, because this is something that all of us, all of the public water agencies have to look at very critically. But I think, you know, this 2.2 ratio, you know, through what I would consider a relatively conservative methodology, you know, really kind of just reaffirms the fact that, you know, this $2.20 of benefits for every $1 you invest is great. And I wish I can do that with my own, you know, sort of savings account. But, you know, I think with the sensitivity on the costs, how do you account for future inflation or future cost increases in this BCA that you just, you know, went through in detail on?
So we didn't do any additional cost estimation beyond what the DCA has already done. So we took Graham's modeling and used that as an input. In an economic analysis, like a benefit cost analysis, we do take a somewhat different perspective on costs. Just like we discount benefits, we also discount costs. And that takes account of both future inflation, but also the time value of money, which in some ways works for you. So that's what this, you know, the 2% or 1.4% discount rates are doing. That's the real or post-inflation time value of money that we're doing. I should point out that probably, as you know, the cost estimates that we got from Graham, they do include significant contingencies in different cost components. So there's some provision for, you know, what if we had a cost overrun built into the estimates. But with respect to the benefit cost ratio itself, for a project of this size, it would be dicey to invest in it if you had a ratio of 1.05, something like that, right? That's just too close for a multi-billion-dollar investment. So you'd like to see 1.5 or greater, I think would be sort of typical guidance. So the fact that it's over 2 here, that can account for a lot of contingencies that are difficult to foresee now, ones that were both, you know, for the project and against it. So I think should increase confidence that ex post, this would be an investment that you're glad you made when you look back on it.
How about Tony? Do you have anything? Tony Estromero? No? Okay. Miguel Luna, do you have any questions?
I don't have any questions. I'm very thankful for the thoroughness that was put into putting these numbers together, and that's it. Thank you very much.
Okay. I just had a couple of comments here. And one of them is that with the innovations that you're looking at, I mean, obviously this goes beyond the scope of what we do, which is construction. Is that some of these innovations, would they also sort of past the construction thing, reduce the maintenance costs? I mean, because a lot of people say, okay, well, what happens after you finish? What's going to happen to us? So I'm wondering if what you're doing in terms of the maintenance costs for folks down the road, which might make this even better.
I would put that on the list of other unaccounted for items in terms of our analysis of potential innovations. We did work with DWR to develop the operations and maintenance cost. We included equipment refurbishing and replacement cycles and that sort of thing, as well as the regular periodic work that would need to be done at the intakes and within the tunnel. But you're right. I mean, this is all work that will continue to work, that we will continue to work on, that needs intensive focus to really understand the potential benefits. And that's the whole point of value engineering. That's something that we will continue to work on. What we put forward now are a set of innovations that we feel are highly credible, even at this very early stage. And I hope it came through that we're not trying to take credit for all sorts of things that we aren't able to really get our arms around now. We focus purely on the construction, the direct construction costs, which we do have the ability to reevaluate quantities and then apply those contingencies and apply proportions of the labor associated with it. So we feel like it was a pretty conservative approach to evaluating this set of what we think are really credible innovations, but there's still a lot on the table that we aren't, we're not really into yet, and a lot of things that could continue to happen down the road. So I think that goes into that category of future work that we definitely ultimately will want to consider.
Okay, one of the things I was thinking about as we're talking about, okay, yes, there, I just have to get this activated. One of the things that we were thinking about in terms of when you're talking about the agricultural issues is the, as you fallow lands and as you don't have available water for the agricultural folks, you're dealing not just with water and water prices, but you're dealing also with displacement of workers and displacement of people and basically destruction of communities. And I think that becomes something else that I think we need to continually focus on for the state as a whole in terms of this. And then, and then the seismic risk, some of the public health and safety, as you're talking like maybe, 200 to 300 days of being out of stuff, especially as you go through this. I mean, the idea of public health becomes so critical. And I don't think that can be understated at all. So those are just some of my observations. And then one other thing, which I just wanted, maybe you can even expound on this a little bit more, Graham. It's kind of like when you're talking about costs being flat. I mean, that's a crucial point, because I've had many people come to me and say, hey, it's going up, it's going up, it's going up. So could you just summarize maybe how this being flat really works for people?
I think the easiest way to explain that is remove inflation. I wish I could remove the effects of inflation. We're talking about virtually the same number. although arrived at very differently. And so that, to me, speaks to the quality of the work we did in 2020, although we were in a place where we didn't know near as much about the potential project. But good judgment was applied there, and a lot of people did the appropriate thing in terms of providing their input into that work. We've now got a much more rigorous and detailed estimate, and the fact that we're ended up in virtually the same place, excluding inflation, is what's meant by, really the costs are flat. So we've got a lot more detail now, but we had appropriate assumptions then. And I would expect that trend to continue as we're able to really further understand and better characterize and add more detail to the project, that we would continue to maintain that consistency.
Okay, thank you.
If I could just reiterate something I said earlier that I think is important to keep in mind. While it's true that inflation has driven up the costs relative to 2020, it's also driven up the benefits, right? Household incomes are higher, all kinds of expenses are higher. So in terms of the economic analysis, where we're directly comparing benefits and costs, it's not fair to look at just one side of the ledger and say, well, the project's 4 billion more than it was in 2020. We also have to look at the current level of benefits, and those have gone up as well as a result of inflation.
Okay. Does this kind of bring in also the idea of the co-equal goals of our water delivery and our environmental issues? Gary, maybe that's for you.
I think that we really I talk all the time about the purpose of the project being really to try to address and adapt for climate. And I think that the economic analysis that Dr. Sunding is talking about, where we're really looking at the economic value of reducing shortages and comparing that to the relatively minor unmitigated environmental costs, I think that really highlights the messages that we've been talking about for quite some time.
Okay, great. Thank you so much. Anything else from any of the board members? No? Okay, then I believe we're going to open this up for public comment. So I believe we've got some people who have already basically put their cards in and put their notice in. So shall we take people from the room first?
President Palmer, I have not received any requests from the room. I do have a list of folks that are online. I also want to acknowledge that in our public comment email, we did receive a statement from, one moment. By the name of Richard Lambros from the Southern California group. Oh, sorry, Secure Water Alliance, Executive Director.
Do you want to read that, or it has to be within 3 minutes? Or should we just publish it?
Acknowledge the letter and I will distribute to the board just for your reference.
Okay.
And so,
As long-
starting with the list of the public comment requests that we have received,
Okay.
I'd like to start with Tasia Kiefer. And give me one moment to bring up the timer here.
Just want Mr. Lambros to know that we will see your letter, and so you have been heard.
All right. I do not see, oh, there she is.
Hi.
Hi. All right, when you're ready.
Alrighty. Hi, everyone. My name is Tasia Kiefer, and I'm here on behalf of BizFed, the LA County Business Federation. We're an alliance of over 240 business organizations who represent over 410,000 employers and 5 million employees in LA County. First, thank you so much to the Delta Conveyance Design and Construction Authority for your efforts on this and to move the Delta Conveyance project forward. BizFed has been a longtime supporter of these efforts to modernize the water project due to the importance of the project for our region. The businesses, hospitals, energy providers, transportation hubs we unite are all dependent on the flow of clean, safe water. We know now that the cost of doing nothing is estimated to reach billions of dollars, a price that is way too high for California communities and businesses to pay. As demonstrated today in the cost benefit analysis, the Delta Conveyance project will bring billions in benefits to the state of California. Not only will the project create thousands of jobs, but it will also help ensure that the businesses have a supply of water that they can depend on, even in the face of natural disasters and a rapidly changing climate. Please, let's invest in this project to shore up California's aging water infrastructure before it's too late. We strongly support the Building Delta Conveyance Project. Thank you.
Thank you very much. All right, so let's go on to our next public comment, please.
So we actually do have one public comment request in the room. Thank you. And then we just received another. Sarah, if you want to start with folks in the room or proceed with the list.
Okay, sorry, I had to plug in my computer. I was plugging stuff in. It said you're about to be turned off here. Okay, so yes, if you'd like, let's do the person in the room then.
So I'd like to call. I could see, I'm sorry, give me 1 second. Ryan Nance, please.
Yes.
Hello, board. My name is Ryan Nance. I'm with the Western States Carpenters. I just want to start by thanking the Delta Conveyance Design and Construction Authority for your efforts to move the Delta Conveyance project forward. I'm here today to offer perspective from the Central Valleys of California, where I was raised, continue to raise my family, and I still today. So down the street from Mojave. We've long suffered from the diminishing reliability of clean and usable water. The Delta Conveyance Project offers solutions to this unsustainable decline of one of our most precious basic resources. The physical infrastructure of this project would aid in bearing fruit for Central Valley residents, both literally and figuratively. The jobs that are created from this kind of project offer access to apprenticeship, training, and mentoring opportunities through the trades that would perform that construction work. The residents have waited so long for a project like this and the positive impacts it brings to California communities. We're excited about the Delta Conveyance Project, and with your help, look forward to seeing it through to completion. Thank you.
Thank you so much. Anyone else in the room?
We do have, is it Robert Cundy? Did I say that right? I'm sorry.
That's very good. Most people don't get that pronunciation right.
All right, see?
So I actually have one question for each of the presenters. Can the online folks hear me okay? Seems like.
Yep, but you have 3 minutes.
So Graham, you had talked about the contingencies applied to both construction and the other costs. And I thought I heard you say that the 26.8% contingency was applied to each of the construction categories. Did I understand that correctly?
The 26.8% is the level of inflation that has occurred
Right.
from 2020 to 2023. We did our updated estimate in 2023 dollars. And so when we compared it back to the old 2020 cost assessment, we used that 26.8 to escalate that number to give us some reasonable comparison. Contingency was assigned to the updated estimate at 30% for construction costs, 15% for soft cost labor. And then we had a couple hard numbers plugged into the estimate with 0, but most had 15 or 30%.
I thought you said the 26.8% was the Bureau of Reclamation inflation number for construction. Did I understand that?
Yeah.
Like, we're not supposed to really get into
Yeah,
like the
just,
back and forth discussion during this time period.
Yeah, I apologize. Recommendation would be to just allow public comment, and then after the end of the public comment period, we can respond to any questions. And I apologize. It's just
Right.
not really intended to be a back and forth.
Yeah, so it has to be just your comment.
So this should be basically an offline conversation then?
Maybe you get back offline, or we can answer questions later, but right now it's public comment period. And you get to do your public comment. We don't get to go back and forth. It's just the rules,
I understand.
Robert's rules.
So my name again is Robert Cundy. I represent Wheeler Ridge Maricopa Water Storage District, which is one of the beneficiaries of the State Water Project through the Kern County Water Agency. The State Water Project is really the sole supply for the district, which is exclusively agricultural, except for groundwater, which has been improved substantially through delivery of state project supplies since 1971. The number presented by Dr. Sunding of a $1,325 levelized cost per acre foot is a difficult number to assimilate from an agricultural perspective. And agricultural contractors generally are quite concerned with the costs of DCP and really they'll actually be able to pay for it, particularly given the fact that your costs accumulate significantly in the early part of the project, but the benefits don't start accruing until later on. And some future point, well before 100 years pass, the benefits pass the cost and you start getting positive. So the comment is just to express the general concern of the district and the farmers there about the magnitude of the costs and the challenge of understanding those in the changing environment for food and marketing in the future. Thank you.
Well taken, thank you. Okay, anyone else in the room? No, okay, then let us go to our Zoom.
Great. I'd like to call on Cheryl Branch next. She is online.
Okay, thank you. Sorry about that. I just got myself off of mute. I'm Cheryl Branch, and I'm with the Los Angeles Metropolitan Churches. We are a network of small to mid-sized African American congregations and ministry leaders, and we're focused on California's water safety and resources. And I'm really excited to be here today to speak about the Delta Conveyance Project and its crucial benefits for the underserved communities that we represent in Southern California. Many of California's disadvantaged communities, particularly in this Los Angeles region, rely heavily on water from the Delta. And this project is vital to us because it ensures that these communities continue to have access to the most affordable water source currently available. While other sources of water, such as desalination and stormwater capture, are important and play a role in our overall strategy, they are not as affordable as the Delta water. The Delta Conveyance Project is not just about maintaining affordability, it's about flexibility, and it provides multiple options to ensure that our communities can access water long into the future, adapting to various needs and challenges as they arise. Building this Delta Conveyance Project means securing a reliable and affordable water supply for our communities, helping to promote equity and sustainability. So we look forward to working with you and working with all the stakeholders to see this essential project come to fruition. Together, we can ensure that our communities continue to thrive and have access to the water that we so badly need. Thank you, ladies, for listening.
Thank you, Ms. Branch. Okay, next.
Next, we have Marcy Strange.
Hi, good afternoon. My name is Marcy Stanage, and I am the Director of Water and Environmental Relations with Rebuild SoCal Partnership. Today's presentation on the benefit cost analysis is a reminder that our infrastructure is in desperate need of improvements. The State Water Project, which delivers water to more than 27 million people, needs the Delta Conveyance Project to continue as our climate continues to change. This year, Rebuild SoCal Partnership released our report, The High Cost of Underinvestment. This report found, excuse me, that declining investments in drinking water infrastructure have led to more waste and complete system failure. We can't allow that to happen to the State Water Project. As we saw this winter, our current system is not prepared to move and ship water when it is abundant so we can save it for the next drought. We lost out on the opportunity to save enough water for more than 9.5 million people. As today's benefit cost analysis shows, this project will provide billions of dollars in benefits to California in improved reliability and water security. It is clear that now is the time to move forward with the Delta Conveyance Project. Thank you.
Thank you, Ms. Stanage. Okay, next.
Next, we have George Bostros.
Yes, hello, and thank you. My name is George Boutros, Government Affairs Manager with Orange County Business Council, or OCBC for short. OCBC serves Orange County's diverse business community and works with public agencies and academia to ensure Orange County's long-term economic vitality and high quality of life. On behalf of OCBC, I'd like to express our support for building the Delta Conveyance project and thank the Delta Conveyance Design and Construction Authority for your work in moving the project forward towards completion. Orange County businesses and residents alike rely heavily on the state water project for much of our total water supply. Therefore, OCBC supports accelerated development of a secure and reliable alternative conveyance system in the Delta that will significantly improve water supply reliability and water quality. This project will provide billions of dollars in benefits for the state and ensure that our region and California as a whole can continue to thrive. As today's report shows, California would be facing risks reaching the tens of billions of dollars if we do nothing. It is incredibly important that we build the Delta Conveyance project and upgrade the aging infrastructure of the state water project before a disaster strikes. We look forward to seeing the Delta Conveyance project built, and I thank you for your time and your consideration in this matter. Thank you.
Okay, thank you, Mr. Boutros. Okay, next, please.
Just gonna say now, I apologize beforehand if I butcher your last name. Next we have Cedric Farmer.
Good afternoon, everyone. My name is Cedric Farmer, and I am a senior lead organizer at Los Angeles Metropolitan Churches. Water is not on everybody's radar, but we've been ringing the bell over at LA Metro Churches because what I tell folks is you never miss your water until your well runs dry. And so the cost of doing nothing is really staggering. And our communities rely heavily on water from the state water project. And the threat of an earthquake that could cause water deliveries to be stopped for a year or more is really terrifying. And that would really be an economic and humanitarian disaster. The additional security that the Delta Conveyance Project provides is really amazing. So improving the reliability of the state's water project and guarding against seismic risk, that makes the project really a no-brainer. So we are looking forward to moving this project forward. And I want to thank everybody for their time, and you have a great day.
Thank you, Mr. Farmer. All right, next, please.
Right, next we have Kyle Griffith.
Sorry about that. It took just a second to get off mute. My name is Kyle Griffith. I'm representing Californians for Water Security. We're a statewide coalition formed in support of the Delta Conveyance project. The economic or the benefit cost analysis outlined today is really impressive work, and I really appreciate Dr. Sunding and the DCA team for putting it together. We've supported various versions of this project throughout our coalition's existence. And what's really clear is this is the best version of this project that we've seen. There's been a lot of work to improve both the routing of the project and making sure that it's right-sized. And the benefits that this project will provide to the state of California are really remarkable. The more than $30 billion of benefits for California and ensuring that we can protect reliable water deliveries in the face of, an uncertain climate is really important. And it's responsible governance, making sure that our state's main water distribution network is able to handle rising sea levels, as well as, lost water supplies due to climate change is crucial. And, this project has been reviewed time and time again, and our coalition is ready to support public water agencies as, they take this up in the future. So once again, thank you for all the hard work that went into this, and we're looking forward to seeing this project completed. Thank you.
Thank you, Mr. Griffith. Okay, next, please.
Next, we have Dahlia Fonseca. And she is on the phone.
Good afternoon. Can you guys hear me all?
Yes.
Thank you. Good afternoon. My name is Dahlia Fonseca on behalf of the California State Council of Laborers. The California State Council of Laborers has always been a strong supporter of the Delta Conveyance Project and its goal of helping meet California's long-term water supply needs. We are pleased to see the significant benefits the Delta Conveyance Project will provide. Modernizing the state's water delivery infrastructure will create and sustain thousands of good-paying union jobs throughout the state. We are ready to help move this project forward. Thank you for your time.
Thank you, Ms. Fonseca. Next, please.
All right, next we have Jason Pierce.
Hello, my name is Jason Pierce. I'm a field representative with the NorCal Carpenters Union. We're pleased today to hear the analysis on the benefits of the Delta Conveyance Project. The billions of dollars this project will provide the state in improvements to water reliability are critical. We know that state water project is in need of modernization. Upgrading our main water distribution infrastructure will create thousands of well-paying union jobs in the near term and will sustain more careers long into the future. We're looking forward to moving this project forward. Thank you for my opportunity to speak on this item.
Thank you very much, Mr. Pierce. Okay, next, please.
Hello. Next, I'd like to call OSHA Meserve.
Hi there, can you hear me?
Yes, we can. Thank you.
Okay, great. OSHA Meserve, today I'm speaking on behalf of local agencies of the North Delta. I also work with many local entities, including wildlife groups and individuals. Been working on the tunnel project a long time, been waiting to see what this new report would include, and haven't really had a chance to review it, but appreciate the opportunity to hear you guys talk about it to understand it better. I think big picture, the benefit cost analysis really overestimates the benefits and underestimates the costs, especially those costs on Delta communities and the local area. It's especially discouraging to have you all discuss the benefits to agriculture outside of the Delta, while at the same time throwing agriculture in the Delta completely under the bus. To the extent the costs on the communities and the environment locally in the report rely on the EIR, those estimates are completely incorrect because the EIR is inadequate and fails to disclose all the impacts on the environment. In addition, I heard reference to the community benefits program as being roughly equivalent to the costs that you think, or that Mr. Sendig thought would occur from the impacts identified in the EIR. That's completely opposite of what we heard. The community benefits program was not meant to mitigate impacts in the first place. So I think that's very inconsistent with what our understanding of the purpose of the community benefits program was. Also, the benefits to ratepayers and taxpayers within the service area of the State Water Project, which is not the entire state, just part of the state, and it's not country, and it's not productive just because of the State Water Project. But the earthquake risk that was talked about today is not best available science. Readily available information shows that improvements to the Delta levees have made it so that an outage, if there was a major earthquake, which is somewhat unlikely, because we are not on any of the major fault lines here in the Delta, that those outages would be a matter of days. And obviously, the fresh water would come in during the winter in any case. So the estimate of hundreds of days is completely irrational. Sea level rise, same thing, not relying on best available science. And also, there's just been no exploration of what the alternatives are, like shoring up the existing levee system, which you all say you would continue to rely on because you would preferentially pump from the South Delta. So the trade-offs suggested by this project are unconscionable. There should be no more Chinatowns where one community is crushed and the other resources are taken by others. This is not the world that I think we are trying to create for our communities and our children. Thanks.
Thank you, Ms. Meserve. Okay, next.
Next, we have Gabriela Cervantes.
Thank you. Good afternoon, everyone. My name is Gabriela Cervantes, and I am here to speak on behalf of the American Council of Engineering Companies of California. And we are a part of the statewide coalition in support of the Delta Conveyance Project. ACEC California is a 70-plus-year-old nonprofit association which represents over 1,100 engineering and land surveying firms across California, and we are in support of the Delta Conveyance Project. Thank you for all your work.
Thank you, Ms. Cervantes. Okay, next, please.
Next, we have Ed Sanders. Calling Ed Sanders.
Good afternoon. Apologies there. Always a struggle to get the mute button. My name is Ed Sanders. I represent Groundswell for Water and Housing Justice. Groundswell is a statewide grassroots organizing campaign, and we are aimed at ensuring that marginalized communities throughout the state have a voice in the water policy debate. I would offer and remind everyone present today that there are nearly 1 million fellow Californians that do not have access to clean drinking water. There are some 390 water systems that are considered failing and unable to deliver water to their residents. Water's life. We need it for cooking. We need it for eating. We need it to live. And right now, too many of our communities do not have access to water. Climate change continues to whipsaw our water supplies. Drought-like conditions 1 year, atmospheric rivers the next, make predicting the state water management an erratic and oftentimes difficult proposition. This project is something that the state is going to need in order to shore up its water management strategies. And that's the only way that you can guarantee that communities throughout the state have access to water. I would remind folks as we go forward, the presentation today was I thought thorough and deliberate. But measuring the cost benefit for communities that do not currently have access to water is something that we should all keep top of mind. We're a state of 40 million people, and 1 in 40 right now don't have access to clean water. Thank you for the time.
Thank you, Mr. Sanders. Next, please.
All right, next we have Victor Reyes.
Hello, good afternoon. My name is Victor Reyes, and I'm here on behalf of ICA, the Valley Industry Commerce Association. And very briefly, the Delta Conveyance Project is probably one of the most important regions' key proposals for water supply. And it also is home to the business and various residents in the San Fernando Valley that rely on water conveyance through the State Water Project. Modernizing this system will prepare us for seismic threats and the impacts for climate change, which is a sound investment for us to make. Therefore, we look forward to working with DCP on making sure that this project moves forward. Thank you very much.
Thank you, Mr. Reyes. Next, please.
All right, I believe this is our last person on our list, Charlie Wilson.
Good afternoon. Thank you for the opportunity. And Dr. Sunding, thank you for your work. At risk of being Captain Obvious, clearly from what Dr. Sunding presented today, the longer we wait, the more California loses out and is put at much, much greater risk. And so by evidence of that, the clock really is ticking, and the study clearly articulates the value proposition for modernizing the state's water delivery system. From a Southern California standpoint, the State Water Project is the base on which everything else we do is made possible. Yes, we're doing aggressive conservation. We'll continue to do so. Yes, we're doing stormwater. Yes, we're doing recycled water. But all of those things, as was articulated in the study, come at a much greater cost and need to be blended over time to keep water affordable for those that we're trying to deliver. It also, from a volumetric standpoint, becomes technological and feasible to try to replace the volume of water that could be had through the State Water Project as it is currently designed with these improvements. So I guess the analogy I would make is it's a lot like today, you've got an opportunity to repair your roof and seal your windows and put in some more efficient upgrades on your home. Much more valuable, much more cost effective in the long run than it is to tear that house down and try to build it from scratch. So we appreciate the work you've done. I appreciate the study and the review today. We'll certainly dig in much deeper and provide additional comments as they become appropriate. Thank you so much.
Thank you, Mr. Wilson. Okay, anybody else? Nope. All right, now according to Robert's rules, we can actually come back to comments from the board. So do we have any additional comments from the board? No? All right, then, folks, is there anything you'd like to add to help us better understand some of the material you presented today? That was a big silence. Okay. Okay, then, ladies and gentlemen, let me make sure I'm following my, oh, turn your phone off. You get a deduction from that. Okay. Anyway, after that, then, ladies and gentlemen, we are adjourned. Thank you so much.